So welcome to today's deep dive. Usually when we talk about orbital mechanics, there's this expectation of absolute precision.
Oh, totally. The giant Swiss watch analogy.
Right, exactly. You look through a telescope and the planets are just neatly in their lanes and the astronomer points and says, there it is. But looking at the data for today's deep dive, that Swiss watch is totally smashed.
It really is.
We are looking at a celestial landscape that's just defined by incredibly violent collisions.
Yeah, and the scale of what we are observing right now is staggering. Take the young star Gaia 20Ek. It's sitting about 11,000 light years away.
Okay.
And astronomers observed it suddenly dropped in brightness, which was followed immediately by this expanding cloud of infrared-emitting dust.
So what exactly caused that?
What we're actually seeing is the aftermath of a catastrophic planetary collision. The shattered debris is physically crossing our line of sight and basically blocking the starlight.
Okay, let's unpack this. So the flickering isn't the star itself acting up. It's like a cosmic hit and run, and we're just seeing the smoke left on the highway.
Precisely. And what's fascinating here is it's really not an isolated incident. NASA just recently found two ultra-dense stars merging inside a dwarf galaxy.
Wow.
Yeah, and this was buried within a massive stream of gas. Meanwhile, the James Webb Space Telescope is detecting the signatures of these, monster stars colliding.
Wait, monster stars? Really?
Yeah. And these aren't just destructive events. The sheer kinetic energy and mass cooling together during these mergers is likely the mechanism that triggers core collapse, which spawns the universe's first giant black holes.
Oh, I see.
So the destruction is actually the engine of accretion and creation.
So for billions of years, the universe has just been smashing things together to build new worlds.
Exactly.
But looking at the new measurements from NASA's DART mission, it seems we aren't just passively watching this demolition derby anymore. We've actually entered the arena.
This represents a profound shift. Because back in 2022, the DART mission intentionally slammed a spacecraft into the moonlet, Dimorphos.
Right.
And we knew the kinetic transfer shortened its orbit around its parent asteroid, Didymos. But the updated calculations show something much bigger.
Oh, what did they find?
By altering the moonlet's velocity, we actually shifted the center of mass for the entire binary system. We changed the whole system's trajectory around the sun.
Okay, but wait, let me push back on this a bit.
Sure.
If we smash a spacecraft into an asteroid at 14,000 miles an hour, didn't we just create a massive cloud of shrapnel?
That is a very valid concern.
Right, because aren't we just playing cosmic billiards, trading one big rock for a shotgun blast of debris that could cross Earth's path anyway?
It's a critical question. And when the impact occurred, it did eject over 1 million kilograms of rock.
See, that sounds bad.
It does. But if we connect this to the bigger picture, the precision of planetary defense is incredible. That ejecta was directed in a way that transferred maximum momentum to the asteroid. So the recoil acted almost like a thruster.
Oh, wow.
While keeping the debris field safely bound to the local system, or just harmlessly dispersed. We engineered a kinetic impact down to the millimeter. It proves we can fundamentally alter celestial mechanics.
It's just wild to think we have that level of control millions of miles away in deep space. But right here in our own orbital backyard, we're dealing with sort of the exact opposite problem.
We really are.
Because we have NASA warning that the 1,300-pound Van Allen Probe A is re-entering Earth's atmosphere years sooner than expected.
Yeah, and the mechanism here is currently entirely out of our hands. It's solar activity.
How does the sun pull down a satellite exactly?
Well, when the sun is highly active, it heats up Earth's upper atmosphere, causing it to physically expand outward.
Ah.
And that thicker air catches the defunct satellite, dramatically increasing atmospheric drag and accelerating its orbital decay.
So it's like we've spent decades throwing thousands of heavy boomerangs up into the dark. We assume they'll just stay up there forever, but eventually the atmosphere swells up, catches them, and pulls them right back down.
That appropriately captures the irony of our current space age, honestly. We possess the technological prowess to redirect a binary asteroid system in deep space.
Right.
Yet we remain entirely vulnerable to the unpredictable atmospheric drag on our own falling space debris. The probe will mostly burn up, so the risk to you on the ground is microscopic, but the lack of control is just glaring.
So where does that leave you, the listener, when you look up at the night sky?
hopefully with the realization that the universe isn't some pristine, predictable museum.
Yeah, it's a profoundly dynamic system of kinetic impacts, just a giant colliding pinball machine.
Exactly. And humanity has officially moved from observational astronomy to basically civil engineering in space,
Right, we are actively altering celestial mechanics to protect our planet.
transitioning from mere observers to active participants in the solar system's evolution.
Which leaves you with this final thought to ponder. If we now possess the actual power to alter the orbits of celestial bodies to protect Earth, when does our responsibility shift? Like, when do we go from merely surviving the solar system to actively managing its architecture? When do we stop just watching that smashed Swiss watch and start rebuilding the gears ourselves?